Welcome, everyone. I'm here to talk about Cloud Native Java with Spring Cloud Services. My name is Chris Sterling. I'm the product manager for Spring Cloud Services. We also got some of our team up here, so if you have questions afterwards, please let us know. Here's an outline of what we're going to talk about today. I'm going to let you look at that for a moment, but I'm going to jump right into it because I have 30 minutes. Not very much time to give an overview of Spring Cloud Services, so I'm going to jump right in. So Spring Cloud Services actually is kind of intended for these microservices architecture. In fact, it came out of a lot of the work that Netflix did, and later on that they open sourced their Netflix OSS. Now what happens is with a lot of our customers, they start out with a Spring Boot app, and that Spring Boot app leads to more apps, and then over time, some more apps. And it becomes so popular that, boom, all these other apps start dropping into place, and it leads to a proliferation of these microservices. Some problems actually come in as we start to see this happen to customers, where they start to figure out, we're actually bringing up and down these Spring Boot apps all the time. That means I have to discover them dynamically somehow, so service discovery becomes important. Also, since these apps are coming up and down, or maybe they're having faults, we're actually going to have to deal with what do we do when it's not working quite right. So we have circuit breakers. In addition, I also want to provide configuration to these microservices in a way that's consistent. And so I need to externalize the configuration or centralize it, and then provide it to those services at runtime. So Spring Cloud OSS actually created a wrapper around the Netflix, along with the config server, which is actually part of only Spring Cloud. And they created these projects around Eureka, Hystrix, and config server to meet these needs. So Spring Cloud Services for PCF takes that OSS, the Spring Cloud OSS, and tries to make it easy to use, wrap some security around it, and also makes it more reliable on top of the Pivotal Cloud Foundry platform. So what do we mean by ease of use? Well, one of the things that we do, when you're actually developing your own Spring Cloud config server, or any kind of service at Eureka or Hystrix, what you have to do is create a boot app. You have to add some starters to your app. You have to enable, using an annotation, whatever type of service you're trying to create. You have to add some configuration. You have to decide if you want to add some security on there, and then you need to deploy it and then manage any updates to that particular app instance that represents a Eureka server, represents a Hystrix dashboard, whatever it might be. In Spring Services, we actually work on top of Pivotal Cloud Foundry, so we get to take advantage of what Pivotal Cloud Foundry has to offer. So one thing you could do on Pivotal Cloud Foundry is just do CF create service. And now I can have my Eureka service up and running and then bind my applications to it and use it. So from a client point of view, what I might have to do if I was just using open source, I'd have to create a boot app, add the connector starters, the client-side starters, add some configuration that actually tells it, should I bootstrap the Eureka first or the config server first? And then I'd have to decide on what environment profiles I might need for local development versus cloud development. And then I have to add some security in there as well. Now in Spring Cloud Services, we've made that a bit easier. Right now you can create a Spring Boot app, you add our Spring Cloud Services starters, and that allows you to now connect and bind directly to that particular service instance and go ahead and go through the OAuth flow that I'll show you in just a couple minutes once you bind your service and get it connected to the config server or Eureka or your Hystrix dashboard. So from a security standpoint, what we added is there's this nice thing in Cloud Foundry called UAA. This manages users, authentication, and authorization. And so one thing that we can do here is when someone asks for us to create a service and then bind an application to our service, we can generate some credentials, provide those credentials in what's called the VCAP services environment variable back to the client application, And then that client application can use those credentials to do a token exchange with the UAA server, get a token that they can then use to make calls to the API for any one of the service instances. Now, what's nice about this is now we've taken care of kind of how do we make sure that not just anybody can hit my Eureka server, not anybody can hit my Hystrix dashboard, not anybody can hit my config server and grab all my configurations. We now have a way of authorizing access to these. And the last thing from a reliability standpoint, you've kind of heard a little bit about this in the keynote this morning. Pivotal Cloud Foundry really kind of provides this reliability. You have the ability to scale up apps horizontally, just CF scale. You have the ability to access health endpoints. You also have the ability to actually integrate with the different components on the platform. And those components themselves, such as UAA, could be horizontally scaled, made reliable themselves. So that's how we get that reliability, providing the PCF integration. Now, we stand on the shoulders of giants. There are many people in this, at this conference that have created these cool things, including Craig Walls and some of the other folks, Josh Long. Spring Boot, Spring Cloud, Netflix, config server, connectors, Spring Security for the OAuth flows. We have AMQP because we actually use Rabbit in some of our services. You have a lot of projects here that enable us to make something like Spring Cloud Services. Now, Spring Cloud Services itself actually is based around the idea of a service broker. So when you deploy your own open source version of a Spring Cloud service, you're actually using Spring Boot directly. You're actually deploying your own app. What we do is we're taking a request to create a service. And we use a service broker API that's an API that could be used across multiple platforms, including Cloud Foundry, in order to do that. So how does a Cloud Foundry service broker work? Well, within our service broker, we have to tell Cloud Foundry, hey, we are a service broker. Please take us into your catalog and show the services that we provide. So there's a get catalog endpoint. Now, when Cloud Foundry gets a request to provision an instance, we get that request and we do a create call. Now, if an application comes online and says, oh, now you have that service that exists, and I want to bind to it so that I can have access to that particular service, now I do a binding, okay? And then, of course, I can delete a binding, and I can delete an actual service itself. So what Spring Cloud Services does is, in behind the scenes, it's implemented all of these endpoints and actually has something called the broker app that's actually deployed into Cloud Foundry just as another boot app. And then we also have a worker app in order to help us with asynchronous conversations rather than have the broker app stop on a particular thread. We use RabbitMQ to send the messages and provide that ability to handle multiple calls. Now, of course, you might have heard of reactive. We've been looking at that quite a bit lately. But this was built many years ago before we had a lot of these reactive APIs that we have today. So this is how a Spring Cloud Services service broker works in behind the scenes. Now, once I have my broker up and running and I've enabled it in Cloud Foundry, I can start creating some of the services. So I'm going to go one by one, just give you a little overview, a taste of each one. Wish I could write some code, but today we only got 30 minutes. We're down to 20 now. So we have a config server. Here's an overview. What the config server allows you to do is actually centralize your configuration and provide that configuration properties to an application at runtime when it's bootstrapping. Okay, so you can deploy a new config server instance by doing cf create service. We actually support in Spring Cloud Service very specific backends. One is HashiCorp Vault. This is if you have some real secrets that you don't want to provide outside. And then we also allow you to support any number of Git backends. So these would be Git repos that you would have access to and provide configuration from into your config server. We also allow you to do basic auth and SSH private key authentication to your Git servers. So now we can have some secure communication between our config server itself and pulling the properties out of a Git repo. And then we allow composition of multiple backends. So what we've seen in practice is a lot of folks who have a Vault implementation, they already bring their own Vault. They actually will have their Vault maybe as the initial composed backend, but then in the array, they'll also add some more backends, such as multiple Git repos that they're pulling configuration from at runtime. So how you might set up a composite configuration, here's an example. I give it a little bit of information about my Vault itself, where its host and port and scheme is, and then I also give it a Git repo. And I can only give one Vault, but I can give any number of Git repos as backends that are providing configuration to my config server. And what's interesting about this is now these provide the properties themselves to my config server, and now the config server has pulled that information into memory, and when a request comes from a client application, hey, give me the configurations that are authorized for me, my application, what will happen is the config server will provide those properties to the client application. So at runtime, during bootstrapping, I now have these properties that I can use, and as a client, I can say things like @value annotation, give me this property value, and post it into my variable. Now, Service Registry. Service Registry allows for service discovery on the platform. And for each time you do a create service, it deploys a Eureka server. So one thing that we ensure is that only applications that are bound to the service registry are able to register themselves or figure out what services are available from that particular service registry. Now, how this works is you got fortune teller service. It says, hey, I'm the fortune teller service. Hello. And then on the back end, you might have a future teller UI who's saying, hey, can I get one of those future teller services? The service registry says, here's all the information you need in order to connect to that particular service. And then the UI go ahead and use that information to get some information from that service. So it's a basic flow that you go through for service discovery is register, find a service, call the service. All right, and I'm going very quickly through these. Hopefully, if you have any questions afterwards, we can have a discussion and continue the conversation afterwards. So a circuit breaker, what we allow here is we actually create a dashboard for your circuits that are enabled inside of your applications. You can create a new circuit within an application by doing @Hystrix command. So underneath the covers, it's using the Netflix OSS Hystrix within Spring Cloud OSS, and then providing that as an annotation that you can then decide, hey, if something goes wrong with this call that I'm making maybe to another service, I can have a fallback method, maybe call to a cache, maybe call to a default piece of information, and provide that instead of just falling over and toppling. Now, we provide the Hystrix dashboard itself when someone does a CF create service, and we also deploy a Turbine app. What that allows us to do is aggregate metrics from many applications, because when you're on a cloud-native platform, I might scale up my application to 3, 5, 7 instances, because I need to horizontally scale to meet the traffic needs. In addition, we also use RabbitMQ in behind those in order for them to collect the aggregated analytics. So here's an example of what you might see in a circuit breaker with multiple apps. As an app comes online, it starts sending its metrics information in. Second app comes online, it'll also send its information. Whoops. And then at the end, the dashboard itself will start to show some circuits and how they're performing, whether or not they're up and running or if they're getting any faults, like in that case with the excuse me, the red marker, or the green marker down below. So now I have one-stop shop to look at a dashboard and find out how are my services performing, how are my circuits performing that are trying to connect to those services. All right, so now how do I get this all going for my client apps? We've actually provided something called Spring Cloud Services Connectors and Starters, and you can put these into your build file, whether it's Maven or Gradle, and add these client dependencies into that file. Now with these, it'll already do things like go through the OAuth flow automatically and get you bound to the service instance and allow you access to start doing API calls. So we've kind of taken all that legwork out of the way for you. We've handled the security. We've handled the actual calls into the APIs. Now, I want to jump into what's happened since last year, because we've had this talk over multiple years. There's even some people in here who might have used Spring Cloud Services previously. Some of the things we've been doing recently is we added pure replication across multiple service registries. So now I might have a PCF foundation in East Coast and West Coast of the United States, and I can have those peer replicate to each other, saying here's the services that I provide or that have registered with me to the other service registry. The other thing that we have is we actually have a little bit more information about the URI in specific instances within a particular service registry. So if I have an app that said, hey, I'm the Fortune service, I can actually see each instance of that Fortune service that's deployed into PCF. To give you an idea of how the peer replication works, here's a little diagram. So you might even have West, East, and Central. They're peer replicating with each other. Now, app B can actually call a service in one of the other locations if their local instance isn't available. Okay? This allows you to have low fault tolerance even across foundations. So in 1.3, we actually delivered in February. We also added encryption support on your config server. So I can actually give a config server instance a key that it uses to encrypt values, and then I can put those back into my Git repo using a cipher prefix, and now those values can be read at runtime as the actual value. And then in 1.4, we added the Vault support and Composite backends that you had seen earlier. Also recently, we added a CLI plugin for CF. So if you're used to using the CF CLI, you can now install the plugin for Spring Cloud Services. You get all these nice commands. You can even stop and start your backend application instances that represent the Eureka server, the Histrix server, etc. And then you can also get some information from Service Registry or encrypt values on your config server. We also have the connectors updates that we've done over the past year. We've enabled container-to-container networking using the direct registration method. And then we've also added Vault support and redacting of properties that are sourced from Vault. We don't want to show those off since they were secret in the beginning. Now, what's coming? So this is interesting. Here's Safe Harbor statement. Read that really fast because this is what keeps me out of trouble. What we're coming out with in 1.5, and what I mean by soon is very soon. And what we're coming out here is Edgeware support. So Spring Cloud OSS Edgeware is the new version of Spring Cloud OSS that's coming out. And on top of that, we're also going to be integrating with one of the Cloud Foundry projects called CredHub. This is a way to actually manage secrets on the platform. Our service broker will integrate with CredHub and automatically store credentials there if you enable it. In addition, we also have configurable data services. So typically in the past, you had to have installed 2 other Pivotal tiles, MySQL and RabbitMQ. We still recommend doing that, but we now support another version of the MySQL for PCF tile. It's the version 2 tile version, and you can now use that instead of the version 1. Along with that, you can also use your own Rabbit or MySQL if you like. And then we also allow for some config server backend enhancements. So now you can use the composite backends and not have to use what we used to use was git.repos that allows someone to use Vault and Git now together and still have the ability to filter out properties for a specific application using search paths and pattern. Now, something that's entirely different that's coming out soon, probably Q1 of next year, and that is Spring Cloud Dataflow for PCF. So Spring Cloud Dataflow open source has been out there for some time. Customers using it since 2016 to create data pipelines. We're actually coming out with a tile pretty soon, so you can do CF create service again. And now you can create a Dataflow server a metrics aggregator, and your skipper application package manager. This works directly out of the box with MySQL, Rabbit, and Redis for PCF tiles. And then, of course, you can also use your own data services if you like, a relational messaging and a Redis data service. You can add those in for your particular instance. So there's more information here. I'll be providing these slides online. Also, I think they'll be provided with the conference itself. And so you can go and find out more information and start playing with your own data flow pipelines. Now, how much time do I have here? All right, I've got actually 8 minutes. This is amazing. So I wanted to point out a few other things that are going on at this conference that you might be interested in if you came to this talk. So one of the things that I found that was out there is orchestrating microservices with Spring Cloud Data Flow. Actually, Mark Pollock is doing a great talk. So rather than going to some of those locations for the documentation, you might find out a lot about Spring Cloud Data Flow there. We also have something on Spring Cloud Gateway. This is something brand new using the reactive APIs, allowing you to filter traffic going to particular endpoints on your services. This can be very much something that, as a cloud native developer working on Pivotal Cloud Foundry, you might be able to be interested in as you start to get further down the road. On top of that, one of the things that we find in a lot of cloud native Java implementations is that you have a service and now you have a contract for your API that others probably expect you to have going forward if they're using your service. So Spring Cloud contracts is something that I highly recommend that you get to know a bit about. And one of the cool things that we've been recommending to customers recently is if I'm a service provider, what I can actually do is not only provide the contract tests that verify that my service is working as expected, but I can also say, here's an actual proxy that you can use to connect to my particular service and use my APIs. So now I have something that allows me to not only provide the actual API behavior as expected, but I can actually give you a client that will be able to connect to me as a jar file that's a dependency in your project. Another thing that you start running into as you get into microservices further is observability issues. We showed something that was very interesting, which is the Hystrix dashboard, right? Circuit breaker dashboard that allows you to give visibility into circuits that you've defined inside your applications. But what about all the connections from the outside that are going through your systems if you have multiple microservices? How do I get observability on those? So tracing and Zipkin are something that you might be very interested in to help provide some of that visibility into the actual request calls and how they're going through your stack. All right, and then there's a couple other ones I'm just very interested in, how they start to implement or how they start to fill out our capabilities in terms of cloud native. And that is one, Skipper enables you to actually deploy applications, microservices, and keep versions on those, allow you to even potentially go back to a previous version if you'd like. But Skipper is something that I highly recommend you get a little bit familiar with as you get into these platforms, along with serverless. So Mark Fisher is going to be doing a talk on serverless Spring, and I highly recommend looking into that if you're interested in functions as a service. I start to see that as you get into patterns like event sourcing and CQRS, functions become kind of a cool tool that helps you enable those particular patterns. Okay. So those are some of the things you might be interested in. And with that, I think I was a little bit early, so I would love to actually have some time to hear some of your questions, if there are any.
Will it be required to do replication for config server, or just
What's required?
replication?
Oh, replication of configuration. So each config server itself actually is getting the information pulled into its in-memory state, okay? So there is nothing that actually pushes into the config server. The config server itself is pulling the information in. So there's no need to replicate that. So as each config server instance comes up, it'll pull the properties that it's supposed to expose. Okay.
So I think you said that PCF, multiple versions of PCFs, we can run Eureka service and find a service in a different PCF service. Is that easy to configure? Because in my org, we have multiple, we call them pools, and we're not able to use Eureka service to find our services deployed in, say, Asia pool versus North America pool. Is that easy?
Yeah.
Is that new, first of all?
So yeah, the question is the peer replication easy to set up between multiple service registries? And it's something that we've supported since 1.2. I'm going to go ahead and go to that slide, if we can go there quickly. It's nice to have builds like that that slow you down. All right. Oh. Sorry, I have it down below. So when I set up peer replication using Spring Cloud Services, we've actually provided a declarative language for doing so when you create your instance or when you update your instance. So what you give it is a list of peers in an array. So you just give it the URL of the other service registry that was built on whatever other foundation. It does have to be another Spring Cloud Services service registry. It can't be just a random open source Eureka, for instance. It does have to be one of our own. And then it does a token exchange to make sure that we are secure communication between the two. But yes, you can give it an array. So let's say you had all three of these locations, and I was the service registry in the middle, in the central. I would give my peers list would be an array of the west and the east service registry that I want to peer with. Yeah, so it is fairly straightforward.
The multi-git configuration server, I guess that's very new. Do you have any examples, or who can I reach out to?
Yeah, so actually, what we recommend is using the configuration that I had shown previously, something like this. But what's nice is I can give it as many Git blocks as I would like. So this is an array. You see the composite is an array with the square bracket. And now I can list my vault or just multiple Git backends that I want. They're just objects in that array.
Is this something new? Because I think it was not supported until the recent version, right?
Yeah, it actually came out in 1.4 in our 1.4 release, which is our most recent actual release. We have an upcoming 1.5 release soon. That came out in September.
In a situation like that, how does it resolve like which repo has you configured? If you have multiple backups of each other, or is it like kind of an aggregate of all the properties and all the different repos?
So here's where these guys keep me honest, but it's an ordered list. And so it'll decide based on the property name to get it from the first one in the list.
I see. So if you have the same property, multiple ones, it'll
Yeah, they won't clash. It'll get it from the first one.
Where does Spring Cloud config server compare to Spring config server? Like I know that at one point it was behind 80%, 60%.
I don't have a percentage, but I do know there are some things that people want to do with Spring Cloud, the Spring Cloud OSS config server, that we don't support in Spring Cloud Services config server. And so we're going to be working on that actually in 2018, and I hope that we resolve that issue. In fact, I'd love to have your feedback, and please talk to me afterwards. We can talk about where that might go. All right? Is there any other questions? All right, we're only 1 minute over. Thanks a lot, everyone.